dear students, warm welcome to our chemistry class. Today we are going to discuss about the continuation of characteristics of elements. Here we discuss about D block and F block elements. These elements are very important elements in our modern periodic table. We know what is meant by D block elements. Yes, elements in its subshell electronic configuration, the last subshell, that is the last electron filled subshell is D subshell. Therefore, the element becomes in D block element. Here in modern periodic table, 3 to 12 group includes D block elements. D block elements also known as transition elements. What is meant by transition? Transition means gradual change. Here gradual change includes metal to non-metals. That is, these D block elements show gradual change from metals to non-metals. However, these D block elements all are metals. Then look the figure. This is the figure of D block elements. D block elements start from 3 to 12 groups. These D block elements are also known as transition metals. Then the peculiarity of D block element are the outermost subshell electronic configuration of the transition elements are generally the same in group and also along a period. Therefore, they show similarity in properties in group as well as in period. Then they can form colored compounds. They show different oxidation states. These D block elements can be used as catalyst. Do you know what is catalyst? Catalyst is a substance or a chemical which alter the rate of chemical reaction without directly participating in a chemical reaction. These are the characteristics of D block elements. Here the properties of D block elements are discussed. Here very important properties of D block elements are, first one, it shows similarity in groups as well as in periods. And next important property is it shows variable oxidation states. Then we can discuss about the first property, that is it shows similarity in groups as well as in periods. We already know that is in group all elements shows similar properties. Therefore, these elements are included in same group. That is, the elements in each group shows same properties. That is, same chemical and physical properties. It is already said, it is obey in all groups. But in the case of transition elements, this rule is obeyed in period also. That is, the elements in period, that is, elements in each period show same property. What is the reason? Yes, reason is the outermost shell contains same number of valence electrons. Then, next property is discussed. It shows variable oxidation state. We already said in S and P block elements, the oxidation states of that elements are definite. For example, in S block elements, the oxidation states may be +1 or +2. That is, the element which show +1 oxidation state, which always shows +1 oxidation state if that element combine with any other elements. But in the case of D block elements, and each element show different oxidation state. For example, we know Fe, that is iron, is the D block element. Then here two examples are given. Ferrous chloride and ferric chloride. Each compound contains iron and chlorine. Then in the case of first compound, that is ferrous chloride, here we want to find the oxidation number or oxidation state of iron. We already know the oxidation number of chlorine because chlorine is a P block element. It is 17th group element. Its oxidation must be -1. It is not changed. It is definite. Then we put this oxidation number here. We already discussed in 9th standard, in any compound, the oxidation states, that is the sum of the oxidation states should be 0. That is sum of the oxidation numbers of the elements in a compound must be 0. Here I given X, that is the oxidation number of iron. How many atoms of iron are there? Only one atom. Therefore 1 into X plus here 2 atoms of chlorine. Therefore 2 into oxidation state of chlorine. Oxidation number or oxidation state of chlorine is -1. Then this must be 0. 1 into X plus 2 into -1 minus 2. That is equal to 0. Therefore, X equal to plus 2. Here, oxidation state of iron is plus 2. Then the other example, ferric chloride. Here also, one iron atom, 1 into X plus 3 chlorine atoms. Therefore, 3 into -1. The sum of these must be 0. 1 into X plus 3 into -1, 3 equal to -3 equal to 0. That is X equal to plus 3. That is here iron's oxidation number is plus 3. That is iron, it is a D block element which shows different oxidation number. That is, in this case iron's oxidation number is plus 2. Here iron's oxidation number is plus 3. Next we can discuss how this oxidation state or oxidation number is varied. Okay? From these examples, we found that iron exhibits two oxidation numbers, that is Fe plus 2, Fe plus 3. Then we can write the subshell electronic configuration of this ion. First one, Fe plus 2. We know iron's atomic number is 26. That is, iron has 26 electrons. But when it is become positive ion, that is plus 2 ion, it donates 2 electrons. Therefore, Fe plus 2 ion means Fe plus 2 ion having only 24 electrons. Therefore, we can write that 1s2, 2s2, 2p6, 3s2, 3p6, then 4s2, 3d6. This is actually the subshell electron configuration of Fe26. We know in a chemical reaction, the electrons in outermost shell is participating. Here, the electrons in outermost shell is donated. For Fe plus 2 ion, Fe donated 2 electrons. Therefore, here 2 electrons are donated from the outermost S subshell. Then the subshell electron configuration becomes 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. Here we must remember that the electrons donated must be in the outermost shell. Therefore, 2 electrons are donated from the 4s. Therefore, the subshell electronic configuration of Fe plus 2 ion is 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. Do you follow me? Then another example, that is Fe plus 3. Here 3 electrons are donated. But we already said that the outermost shell has only 2 electrons, that is 4s2. Then again 1 electron is donated. Then that 1 electron is from the penultimate shell. What is penultimate shell? That is just before the last shell or second from the last. Therefore, here the subshell electron configuration becomes 1s2, 2s2, 2p6, 3s2, 3p6. Here we know 3 electrons are donated. 2 electrons are from the outermost 4th S subshell. Then 1 electron is donated penultimate D subshell. Therefore, here 3d5. What is the reason for that? Because outermost S subshell, that is in D block elements, outermost S subshell's energy and penultimate D subshell's energy is very low difference. That is slight difference in energy between outermost S subshell and penultimate D subshell. Under suitable conditions, the outermost S subshell and penultimate D subshell's electrons participate in chemical reaction. Therefore, this is an important topic, that is D block elements show different or variable oxidation state, because for D block elements, outermost S subshell's electrons and penultimate D subshell's electrons participate because of low difference in energy. We already said that a character of D block element is it can form colored compounds. Most of the colored compounds consist of transition elements. Here the color is given by the presence of transition elements ion. For example, here copper sulfate, it is a blue colored compound. This blue color is given by copper ion. Next one is cobalt nitrate. Its color is light pink. Here light pink color is given by cobalt ion. Next is potassium permanganate. Here its color is violet. This color is given by manganese ion. Next one is ferrous sulfate. Its color is light green. The color is given by iron, that is ferrum ion. Next, ammonium dichromate. Its color is orange color. This color is given by chromium ion. That is most of the colored salt. Here transition elements are present. Next, we can discuss about the characteristics of F block elements. Like other blocks, that is S, P, D, here F block elements last electron is filled in F subshell. This F block elements consist of two rows just below the periodic table. First row is known as lanthanoids, second row is known as actinoids. This row consists of 14 elements each. In F block elements, last electron is filled in F subshell. This F subshell is in anti-penultimate shell. What is meant by anti-penultimate shell? We already said in D block penultimate shell. Penultimate means just before the last shell. Then anti-penultimate shell means just before the penultimate shell. That is shell that is just third shell from the last. For example, this is the subshell electronic configuration of cerium and uranium in short form. In cerium, it is written as xenon 4f2 6s2. We know xenon's atomic number is 54. Then last electron is included in fourth shell's F subshell. Here outermost shell is 6. Then penultimate shell is 5th. Then anti-penultimate shell is 4th. Therefore, here anti-penultimate F subshell. Another example, uranium 92. It is written as radon 5F4 7s2. Outermost shell is 7th, but F subshell is included in 5th shell. Here 5th shell is anti-penultimate shell, that is from third, that is last third, just before the penultimate shell. This F block elements also known as inner transition elements, because actually these 28 elements, that is lanthanoids and actinoids, are in between transition elements. These lanthanoids are 14 elements after lanthanum in 6th period. Actinoids are 14 elements in 7th period after actinium. Then the characteristics of F block elements are very similar to D block elements. For example, F block elements also shows different or variable oxidation state. Then it is also used as a catalyst like D block elements. Then here some elements are used in nuclear reactors. For example, uranium, thorium, plutonium, etc. Here actinoids, that is second row of F block elements. Actinoids are radioactive elements, as well as most of the actinoids are artificial elements. Do you follow me? Yes. Then we can conclude our topic, that is the topic of the characteristics of D and F block elements. I think you get clear idea about this topic. Therefore, you list the characteristics of D and F block elements in your notebook. Thank you.